What does a mathematician have in his garden? Natural logs, roots, and stem and leaf plots. Haha. So today we're actually going to be dealing with stem plots and, well, histograms, which is one way of graphing quantitative data. So we're just doing histograms today. Let's go ahead and look at this histogram. And if you recall in the previous lesson, we talked about bar graphs. And this looks a lot like a bar graph. It's got a graph title. There's height on the bars, which is the same as their frequency. We have a variable here, which is quantitative now instead of categorical. And what's also different is we have intervals here, which cover different ranges of numbers. And we have no real gap. Instead, that number indicates the start of a bar. So if I have an 8, it's in this bar right here. If I have a 16, it's in this bar right here. So I created this histogram using a survey of my statistics students regarding the number of hours a week they work at a job. So histograms have the following characteristics. The graph title tells you what is measured, and the survey question is always a good choice if you're stuck. Instead of categories, the bars represent intervals or ranges for a quantitative variable. The possible values for the variable may be discrete or continuous, and each interval must be the same width for each bar. Remember, in categorical data on a bar graph, those are also the same width. Here, it's extra important that it's the same width because it's covering the same range. Now, the height of each bar shows the frequency or relative frequency for each interval. And because the values could be continuous, the bars touch instead of having gaps like bar graphs. The values in an interval can be anywhere in that interval. They do not need to be at the beginning, middle, or end. And changing the intervals can actually change the shape of the graph. And I'll show you an example of that. So histograms are usually constructed from a frequency table, and here's when I started. This is a frequency table for a continuous set of data. So I go 0 to almost 8, 7.9999, etc. Then 8 to almost 16, and then 16 to almost 24, 24 to almost 32, 32 to almost 40, 40 to almost 48. And we fill in the frequencies from the picture. The interesting thing to know, if you want to know the width, it's easier actually to go from the beginning to compare the beginnings of each interval. So 0 to 8, that tells you a width of 8. 8 to 16 is 8. 16 to 24 is 8, and so forth. So how do we construct a frequency table and a histogram from data? So if you don't have either the frequency table or the histogram, what do you start with? Well, first of all, we need to know how many data points we have. So if I were to count each point, 1, 2, 3, 4, 5, 6, our data set here has actually 28 different points. And what is this? This is from a survey about the number of pairs of shoes my students own. Now, to build the table, we need to, and really the graph, there's a couple things I need to know. I need to know how wide the graph is going to go, and that's going to depend on my range. Then I also need to figure out how many bars or intervals that I need, and this could also be called classes. And then I need to figure out how wide each of the bars are. Once I figured that part out, the rest of it's pretty easy. So first of all, determining the range, step 1 is pretty easy actually. You determine the minimum and the maximum, and then we basically subtract those to get your range. So in this case, I have my minimum, my smallest point is 1, my highest is 27, my range will be 26. Now, the desired number of intervals, you have an option. We like to have at least 5 because then you can, that helps give you some shape. If you only have 2 bars, it's like, okay, it's either like that, one tall one, one short one, 2 even ones, or the other one's tall and short. And that's not much information. But once you have like 5, you can start to get some shape. Now, you can, if you have a lot of data points, have even more bars. You can have up to the square root of n. So if I had 100 data points that I wanted to look at and wanted to get a little more refined on my bars, I could actually have 10 intervals. So here we have 28 data points. That's n, the total of frequencies, or the total number of data points. Take the square root of that, and it's 5.3. And I figured, well, that means we'll just go ahead and stick with 5 intervals. That's fine. Now the width. So if I'm covering from 1 to 27, then I need to cover a width of 26. If I have 5 bars, what could I do? Well, I could divide it. Just take the range divided by the number of intervals, which is 26 divided by 5, and I get 5.2. Now, if I use 5, that would be 5 bars of 5. That would only give me 25. That's not wide enough. So since we don't want to use decimal numbers, we always round up. Now, an interesting thing is if I got an exact integer answer, if my range was 25 and I wanted 5 bars, I still would want to use 6 as my interval width because it's going to be not quite long enough, and you would actually find it out if you graphed it. So always round it up. Even if you get exactly 5, you're going to go to 6. If you get exactly 6, you go to 7. So now we need to figure out where the first interval goes. And most times you can start it at the minimum. And most of the time when I'm using WebAssign, it automatically picks the minimum. Or I personally prefer a number slightly lower, like 0 in this case. So again, multiples of 5 and 10 are popular starting points for a histogram. So in this case, the min is 1, and I'm going to go ahead and stick with 1. All right, but I could have used 0 if I wanted to. And that's going to give me, and I'll show you that graph. I'll show you what that looks like. All right, so calculate the beginning of the remaining intervals. So we're just going to add the class width each time, or the interval width. So if the first interval starts at 1, we add 6 to it. The next one would start at 7. And then the end point of the last interval, you're going to add the interval width to the starting point, but remember that the interval ends just before this value. So since we're using, if we're doing 31 would be the start of the bar after our graph, we could say just before 31. But since we're using integers, we know that it's just, we're going to use 30. So because we're not going to have 30.5 pairs of shoes. Well, I guess you could have 30.5. So here's our data, and here are our intervals. Let's go ahead, 1 to 6. Now see, if I add 1 plus 6, that gives me 7. 7 plus 6 gives me 13. 13 plus 6 gives me 19. 19 plus 6 gives me 25. And I only have the 5 bars in this case. I'm going to show you another one with 6 bars in a little bit. So we just go through and count everything that's from 1 through 6, and we found that there were 14 of those. Then we count anything from 7 to 12, and I found 5 data points for that. 13 to 18 is 3 data points. 19 to 24 is another 3 data points. And then 25 to 30 is another 3 data points. So there they are. Now we can finally construct our histogram. And you can start the one right here. I like to start on, here we go. There's my frequency. I kind of like to start with a little gap, but it doesn't matter. You can start it right up next to the axis. And there the start of each bar. Then go ahead and pick frequency. I'm doing, my highest number was close to, it was 14. So if I do 10 up here, it's not high enough. So I'll just go every 2. Which means I can get to 20, and there's 10. So my first bar is going to go up to 14 right there. My second bar goes up to 5, and then 3, 3, and another 3. And voila, there's my histogram. Notice how the bars are touching. Now, I'm just going to show you if I had used 0. So let's say I had used 0, and I had gone with widths of 5. So now I have 6 bars. This is what this graph would look like. So here are my new intervals and my new tallies. So this would be a perfectly fine graph to do. It's just going to look a little bit different. And see how I'm starting at 0 there. And voila. So I still have this sort of a 3 thing going on back here. But you'll notice this first bar is a lot shorter. I've kind of split the bar a little bit by starting at 0 and 5, and then I have this little low bar right here. And so depending on what you choose, your histogram could look different. Now, another thing when you are doing this, it's good to have a cumulative frequency and relative frequency. Cumulative frequency is kind of like percentile, which I'll teach you. It's, well, relative. Anyways, so cumulative means what you have up to that point. So cumulative frequency from 1 to 6 means how many data points do I have that are 6 and lower? Well, they're 14. All right. Now, how many data points do I have that are 12 and lower? Well, I have the 5 here plus the 14 there, and that gives me 19. How many are 18 or lower? And I add the 3, and I keep adding until I get my total frequency right there. Relative frequency, if I ask you for that, what that means is I want to say, what is this compared to the whole? So half of my data points, 14 out of 28, are in the first bar. So if I graphed relative frequency, my first bar would go up to 50%. 5 out of 28 is 17.9, 3 out of 28 is 10.7, and the last 3 are the same. Okay, so if I graph it, here now I still have the same bars, the same intervals at the bottom, and now what's different is only this part. Since my highest bar is 50%, I've got to go all the way up to 50%. Each one of these are 5%, so there's 25%. First bar goes all the way up to 50, and then we were at like 17% and about 11% for the next 3 bars. And you'll probably notice that looks a lot like the other graph. The only thing that changed was the relative frequency on the vertical scale.